Hello everyone. My name is Thibaut Refay. I'm representing Axens today, and I will present you the complementarity between mechanical and chemical recycling for plastics, obviously. So, why this presentation? It's because most of you are coming from the mechanical recycling world, and you hear about chemical recyclings. So we are the newcomer. Axens is a licensor, so a technology developer, and so licensors for chemical recycling technologies for plastics. And the aim is to explain and highlight why these two models, these two type of technologies are complementary and not competitors. So as we're newcomers, and our goal is to address what is not available as of today on the market as solution to improve the circularity of plastics. So we have identified three main axes where we can focus our energy and leverage synergies between the mechanical recycling and the chemical recycling. The first one is about increasing the closed loop circularity. So by closing the loop, we can valorize products and plastics and resins that, as of today, are not treated by mechanical recycling. So we're talking about opaque PET, multi-layer trays, products that, as of today, there is no solution to have a closed loop circularity. The second step, the second axis, will be to increase the value from our waste streams. So in our garbage, many molecules and many materials are sent then to landfill and incineration, and in fact it's valuable materials. If we want to move on a more environmental friendly way, we need to be able to tackle and tap into that significant quantity of plastics that are today not valorized enough. And the chemical recycling can help with that. And the last point is to open new opportunities, market that does not exist as of today, and where we have identified that in fact the two type of technologies will have to be implemented to address this challenge. So we will talk about the textile recycling. So let's first focus about increasing the closed loop circularity. So here it's market data, I guess you might know them. It's for Europe, PET consumption. So you can see that about 40% of the PET in Europe is dedicated for polyesters, and we will talk about textile later on. And about 60% is for packaging. Out of this 60%, there is the transparent bottle of PET that are mechanically recycled as of today. Good technology, it's working well. Everybody is happy with it, so it's not our target. The target for the chemical recycling is to address the other half of the packaging waste that, as of today, is not recycled. So we're talking about the colored and the opaque PET. We're talking about the multi-layer trays. We're talking about the films. All those products, as of today, have no valuable output. And so it's representing about 2.5 million tons a year only for Europe. So our technologies will focus on this type of feedstock to propose a solution. And this technology is a rewind PET. Rewind PET is also a chemical recycling technologies that we have developed in partnership with a Japanese company, G-Plan. And so it's relying on the glycolysis principle. So you have PET, you depolymerize it by a glycolysis reaction, so you go back to the monomer, you have impurities, we add step of purification to remove the pigments, to remove the fillers, to remove all the impurities you have in the PET, and then you have a pure monomer that is ready to repolymerization. So by doing that, you can achieve a virgin-like equivalent product. So it's a no-brainer for the end users. They don't have to change anything. They have the same quality. It's food-grade compatible. The CO2, because it's one of our targets, the footprint is significantly lower than the virgin PET. You can reduce by 2 your footprint by using this kind of technology, and it's without taking into account the incineration. And it's relying on 10 years of operating experience in Japan from our partner J-Plan, and we have improved the available assets to be able to tackle these new feedstocks. And so the feedstocks, as I mentioned, is on the top. You have a picture of what we can process in the Rewind PET technology. This is a picture of our demo plant in Japan. So it has been modularized. And this is some key figures of our performance. So we're very happy to say that we have processed more than 500 tons of waste packaging, so naming that it is running at nameplate capacity. It's a demo plant, it's not an industrial scale unit. And we have been able to achieve more than 85% yield. So we have very, very little loss of product in that process. And that is a key part to have a much better LCA than the virgin PET. On operation, so we have a track record, everything is recorded, so you could notice that we have more than 60 days of operation without any interruption, and we stopped only because the campaign was finished. It was not due to mechanical or any process issues. So the process is reliable, and the operators in Japan were very happy to have it, because they have less work to do now. And we have accumulated more than 5,000 hours of operation, so we have treated, processed multiple types of feedstock in significant quantities. That has allowed us to fill up tanks like that. So it's filled with pure BHET. And for what purpose? So the purpose like that, any company can ask us some BHET and we can ship them some product and they can test it. They can repolymerize it themselves and to check the quality of the outlet product. But not waiting for what you could ask us to do. We already took the initiative to do some, and so we have been able to produce recycled PET from our BHET. So that's the pictures on the left, on the right part. And so it has been approved in terms of quality by the brand owners, so the major packaging industry. It has got a non-objection letter from the FDA, and we're under processing the EFSA certification. And since we have very well successfully completed our campaign of testing in Japan, the process now is homologated and so ready for commercialization. This is the kind of feedstock we can process. So the colors, the opaque, from Europe, some waste packaging from Japan, and also multi-layer trays that will come from Europe as well. So it's important to have local feedstock to test the performance. The second axis of development for the chemical recycling for us is to increase the value of the waste streams. And so here we will talk about the mixed plastics that you can recover from as a feedstock of incineration or in the landfill. So as per some external sources, they plan to have a significant growth in chemical recycling capacity in Europe, in North America for up to until 2030. So you see this significant growth. What I guess is important to see is final figures because we're starting from nearly zero, so the growths are significant in percentage. And we expect to reach about 10 million tons per year of processing capacity by 2030. Out of these 10 million tons, so some of them will be Rewind PET equivalent, processing PET, but we expect that the big part will be unit relying on pyrolysis pathways. And so addressing the mixed plastics, including the multi-layers. So when you have a mix of polyolefins, it's hard to sort out. So what you could do is using a pyrolysis unit to produce recycled polyolefins. This pathway is the only one that is able to process and to produce food-grade polymers. food-grade polyolefins. For packaging application, for the PPWR, there will be a mandate to add recycled polymers in the packaging, and the pyrolysis pathway for polyolefins will be this, by 2030, the only option available. The pyrolysis pathway now is relying on proven industrial units. We have demo plants. Competitors have demo plants. The performance are shown. We've now several years of operation, so it's proven and robust technologies. And the impact on our environment, sometimes it can be discussed, but thanks to the latest improvement we've made, it's a no-brainer anymore. And so Axens offer on that pathway, you see that the chain is longer than foam PET. You have the bin, so you plastics from the bin, then you need to pre-treat it a little bit to go then to the pyrolysis technology. The pyrolysis will convert your plastics into an oil by doing pyrolysis reaction. And so this oil is getting out of our TAC process. Then we go to what we call Rewind Max, that is internal Axens technology to enhance the yield and the recovery. And so in the end, you get a product that contains impurities, because in waste plastics, you have a lot of impurities, but even in packaging, you always have fillers, additives, things like that are contaminating the oil. That is not suitable for massive processing in steam crackers. So you can have silicones, you can have metals, you have chlorides, nitrogen. These kind of species are not so well appreciated by the steam crackers operators. So to purify the oil, we have developed the Rewind Mix technology that is able to remove all that and produce, in the end, a virgin-like naphtha. So you start from the bin with all the waste, and in the end, you have a naphtha that is equivalent to what you can have from a refinery. So for the operators, in the end, it's a drop-in product, no issue. And you have, as Axens, we have developed partnerships as a different step in order to leverage the expertise of each player. We are not reinventing the wheel, and like that we can put on the market a chain with proven results, with proven technologies, and with the expertise behind. So, proven, virgin-like naphtha. What about the yields? We're able to reach up to 85% yield over the full chain. So we're minimizing the loss, and that allows us to have a CO2 footprint equivalent to the virgin PE. So circular PE would have a similar footprint as the virgin PE, without taking into account the credits of avoided incineration. So if you're in Europe, we have incineration, it's benefits. If you're in the US and there is massive landfill, you don't have the landfill. So you still fix a problem. And because developing projects with so many, let's say, pieces could be difficult for players, for developers, with the chain, the full chain we can propose, we can offer you one single set of guarantees. So you don't have to think anymore about interface between, okay, what happens if the unit before is not doing well? We can manage that for you. And to be able to develop that, we have signed a partnership with Sorema, so a very well-known Italian companies specialized in developing sorting lines for plastic recyclings. And that partnership allows us to find the sweet spot between investing in pretreatment and mechanical recycling or investing in chemical recycling. So depending on the feedstock, depending on the country, it's very important to know what the feedstock is, and it can change from country to another country. And Sorema will help us with that, and we're able to find the proper location to put the capex to have an optimal economics. Last one. New opportunities, so textile recycling. So we said 40% of European PET is for textile. But if you look at globally, on the right part, In fact, it's 70% of the PET production is dedicated for polyesters. So it's for cloths, for garments. And it represents about 60% of all the textile we are wearing. So it's massive. It's massive, and there is no solution as of today. If you look at on the top in Europe, what do we do with our clothes? So most of them are imported first. Then you consume them. You have little side streams. You wear them, and then you throw them. And most of the clothes end up either in landfill or energy recovery, so we're burning it. That's kind of a pity. Even so, but we have 20% of the textiles that are already separately collected. So you have somehow a potential already here. But much less recycled because there is no solution for that. That's where we adapt the rewind PET technology to be able to address and take this kind of feedstocks. But the complementarity with mechanical recycling comes from the preparations that you need. So we have already been able to process feedstocks that have been prepared in the rewind PET, but now we need to industrialize this kind of preparation. And that's relying on mechanical recycling to be able to prepare the feed, valorize all what is not PET, because you have cottons, it would be a pity to destroy it. So there is a room to optimize that path, and then to be able to offer to the fibers a valuable output. Regarding textile, as I said, we already processed some textile in our demo plant in Japan. So it could be the shape and the color depend on how you do the mechanical preparation. But there is some Japanese popcorn that have been processed. Also some polyester textile from Japan. And we're going to process post-consumer textile prepared in Europe. But recycling chemically, it's interesting. You can produce, as we said, rewind PET is going to put on the market monomer that could be polymerized. So you have about 2.5 million tons per year of packaging waste that could be potentially recycled chemically. And on the other hand, in Europe, we have about 2.2 million tons per year of virgin PET production capacity. So we're going to use the same plants as what is existing in Europe. But you see that we can already fairly supply all the PET in Europe if we tap into the packaging waste with chemical recycling. It's balanced. For fibers, it will be a bit more tricky. We are generating a lot of waste, more than 3 million tons per year, and the fiber industry in Europe and the production of polyesters is kind of tiny. It's 600 KTA. So in fact, we have far more waste than fiber production capacity. The good news is we're able to produce in Europe 100% recycled fibers, and we have plenty of them. The bad news is you still have waste to manage. But if we can already do 600 KTA of textile recycling, it could be a good start. So, in conclusion, pros and cons, potential point of attention. So on the positive part, we have now proven technologies on the market, industrially proven. So it's a business case ready for project developers and for financing. We have able to work together to develop new value chain. You have a huge potential in incinerator feedstocks, in textile industry. You have business opportunities there. And it's also a great opportunity for Europe to earn the sovereignty, because we will have our own raw material and generating so industrial added value, and so creating jobs. At the point of attention, I guess you already got the same information this morning if you attend to the presentation. We need clear application rules. We need a clear regulation framework, whatever it is, it has to be set. Like that, we can move on with projects. There is also a challenge on where you're going to recycle the plastics. It's important that the plastic waste that we produce in Europe have an output in Europe. It would be a nonsense to export our waste to somewhere else to re-import recycled material. And finally, it's important to secure that the value chain will still exist when the chemical recycling industry will take off. Our colleagues from the chemical industry are facing headwinds. It's hard for them as of today. It's important to make sure that this industry in the whole value chain can go through these difficulties as of today in order to be able to be ready for recycling and circularity. So I forgot to mention that you need to fill up your questions on Slido. So it's time to fill up Slido if you have any questions. And I thank you for your attention. We already have one question about textile recycling, about nylon waste, and how does it impact the recovery. As of today, it's not foreseen to massively mix the feedstocks to recover nylon. It's the same unit as the PET. The easiest and the cheapest as of today is to make sure you segregate the two work streams. But then, depending on the market expansion, we can still adapt and retrofit our technology to be able to process a wider range of feedstock. But we're starting with 95% polyester rich stream. Later on, we will add more flexibility, but every flexibility we add to a unit at a cost. And so at some point, to start off, to kick off the industry, we need to have proper economics, and so to focus on what is the most profitable. Another easy question: what does TAC stand for? So TAC is a PRSE brand name of plastic energy, and TAC means thermal anaerobic conversion. So it's a chemical reaction in absence of oxygen that enable you to produce oil from a solid. What's the pre-treatment upstream the PRSE process? So typically it's a mechanical sorting. You need to segregate the glass, the paper, the wood, any pieces of stuff you can find in the garbage. And we also sort out the different type of polymers. Because for PET, we have application to recover them. And for polyolefins, we have other type of application. So there is some polymers that we can mechanically recycle. So we extract them as far as we can, because we have an output for that. And what is not valuable, what cannot be recycled in other way, can be sent to the PRSE. For the textile industry, chemical recycling, how do you recover cotton from PET textile? And that cotton is how to handling. So the target is to be able to, it's at a mechanical stage, so it's under development, and the target is to recover the cottons to be able to redo fibers with it. But it's not yet completely finished as of today. What percentage of polyolefin end up as new monomer after PRSE? It's kind of a mass balance question. In the pyrolysis pathway, we convert the polymers into an oil, and then you will process the oil in the steam cracker mostly, and you will have the yield of the steam cracker. Okay, out of the steam cracker, you have about 50% olefins yield, and then with the mass balance application, you have other chemical building block, as it's written, that could be also valuable and considered as recycled. So in the end, we can reach about 70% in the steam cracker yield, and so we have 15% loss on the way. So you do the math, and we arrive around 60-65%. Two monomer. What percentage of circular naphtha can be physically introduced in a new polymer? Through the purification, we can feed a steam cracker with 100% of circular naphtha. If you do the purification, you don't need to rely on dilution anymore. The feedstock is a drop-in feedstock, so it's like for your car. When you put, if there is a grade of 100% biofuels, you just drop it and you run with it. It's the same for the circular naphtha. It will be same as a typical refining naphtha. You just process it, and it's a no-brainer for the operator. What type of catalyst in glycolysis process? Homogeneous or heterogeneous? We don't use any. So it's what's the beauty of the thing is when you start to add catalyst, you need to neutralize catalyst, you need to manage the catalyst. We don't use catalyst. So that's the thing, and that allows us to have a very, very nice operating conditions and no operating issue.
Yeah.
How does it impact LCA versus mechanical recycled PET over virgin PET? So when you compare circular PET from the rewind PET and virgin PET, you have a 50% discount, so on CO2 footprint, without taking into account the incineration. And when you compare to mechanical recycling, we are still emitting a bit more. That's why we don't want to tap into what could be mechanically recycled. That's a complementarity. We have to take what is not already processed, because the mechanical recycling is an efficient process for what it can take. So the goal is not to tap into these kind of feedstocks, because we are less efficient. We have to do chemistry, and so it emits a bit more CO2. Compared to virgin, it's still much better. And about the yield of the glycolysis process, basically it's give 85% yield. So why we're not able to go beyond, well, we are working hard to go beyond that. We're asking often the question to our R&D colleagues. You have losses in our chemical recycling process. You have steps of purification. When you remove impurities, you remove material. We try to be as selective as possible, but at some point, there is a trade-off between recovery and cost, and we are still in a capitalist world, so we have to be profitable. So we try to find the sweet spot between minimizing losses and improving the economics.
Yeah.
Have we noticed much difference in feedstock from Europe and Japan? We're expecting some, in fact not so much as of today, so both are fine. And it's time run out. Thank you very much for your questions, thank you very much for your attention, and I leave you take a coffee now.